Hi everyone, I'm Ziad. I'm from Australian BioCommons, a product manager there, and I look after some of our bioinformatics services. And one of them is the Australian Nextflow Seqera service, which I'll be talking about today. Well, these few slides are just a quick introduction on the Australian BioCommons, which might overlap a bit with what Johan mentioned during his presentation. But generally speaking, we in the Australian BioCommons aim to support life science researchers by providing them community-scale digital infrastructure. This includes software and hardware platforms. We are nationally funded. All our services are fully subsidized for Australian researchers, and we also have training and support solutions. And the way we usually work, we have our engagement team that communicate and engage with life science communities that can be working on specific problems like genomics, genome assembly, proteomics, but also in some situations groups or consortia that investigate specific species like ozark or the Zero Childhood Cancer Initiative. We also communicate and engage with data production facilities, and the aim of all these engagements is to identify common problems they have. Then from our side, we try to find a solution either to avoid these problems or to mitigate the impact of these problems on the researchers. And one of the engagement was with the bioinformatics workflow community. And the aim of this engagement is to understand more about their interests and needs. And we realized that the majority of the users in this community, they develop and reuse bioinformatics workflows. And when we ask them about the common workflow management systems, the majority were interested in Nextflow, then SnakeMake, but also the situations where users will use the tools individually, but run them, sequentially to get the desired output. And in many situations, these users will have access to different compute infrastructure where they run their workflows. And usually they access these compute infrastructures either, cloud services or HPCs through a command line that comes with a lot of problems and challenges. Simply using just the command line is not the preferred way, especially for non-technical users. There are a lot of challenges in, collaborating on these workflows or the same problems, who can access what, and in many situations there will be a lot of replications, deployment of tools or workflow multiple times as people are not aware of what exists on these infrastructures. But also monitoring the executions and like especially for larger scale workflows that run in parallel and multiple nodes can be very hard. Most of the time the information are in different logs, and it's not easy to extract, the relevant information unless there is a parser or there is a tool that does this for you. And as a response to these challenges and the needs, including, the interest of the users in Nextflow, we start working with Australian Nextflow Seqera service. And simply this service is based on Seqera platform, which is a web interface to run and monitor the executions of Nextflow workflows. It's developed by Seqera, which is the company that developed Nextflow. It does support running workflows in different compute backend, including HPCs or commercial cloud services. It also has live monitoring interface where you can see the executions and the progress of the workflow while it's running on different compute infrastructure. It has also an API, so you can utilize the service easily. It also have like a data explorer service where you could explore the data you have through the web platform smoothly without the need, to go and log into the compute infrastructure and investigate the data you have. And the service relies on the users to bring their own compute, where they will configure, then they will have access to. And this is the structure. So the users, when they access the web platform, they will have access to workspaces. And in these workspaces, they will configure all the resources they have, including workflows, compute environment that connect with an actual compute infrastructure in the back through different credentials. And that's like simple structure of the service and how the users will interact with it. So when you access the service, you can access different models. One of them is the personal workspace, which is limited to one user, the owner of the workspace, which is almost the place where you land when you log into the service. And under this personal workspace, the user will add their resources and can utilize this workspace to run the workflows and monitor the executions. It usually has less features than what we call organization workspace. It has more features and actually allows the collaboration between multiple users on these resources. So you add the workflows, the community infrastructure, and you add multiple users with different access permissions to these resources. Then all these resources will become shared with all these users, where they can just interact with it and use it as they want. So to access the organization workspace, it's limited to only 3 users at this stage. And the third model is what we call it analysis service. And for this specific use case, Australian BioCommons, for commonly used bioinformatics workflow, we will configure them on the platform. We'll also provide compute allocation in behind. So from the user's perspective, they go to the service, they only need to bring their data, and they can run these workflows on their data on our compute infrastructure and get the results and use them for whatever downstream analysis they want. Now, the fourth model we have that will expand, to get all the features you need as workspaces. Well, not all the features, but to avoid the limitations on the users' counts for the workspaces is to get access to an organization. So you get an organization on the platform. Under this organization, you can add as much as you want as workspaces, but also as users. So there's no limitations on the users and the workspaces. And all these resources can become, available for the users within these organizations to, collaborate and coordinate their work on the platform. However, the access to a whole organization in the platform require a license fee for this organization, which is a responsibility of the group themselves. But the Australian BioCommons still fully subsidize the deployment of the instance where the organization is working and all the support provided with it, including also the license for the software for the platform itself, not the organization. We were working on a pilot project for the service just to understand more the requirements on having the service in production mode and also assess the interest of our users on the service. And we are at the end of the pilot project, and we're going to launch the service in the production mode, hopefully in the next month. During the pilot project, we hosted 29 groups from 16 different institutions. We had around 78 users. And during this time, the users managed to run around 4,000 workflows that submitted around 300,000 jobs on different compute infrastructure, including commercial cloud like AWS, but also a lot of HPCs, national HPCs like Citrix at Posey or Gadi at NCI, but also on the premises HPCs for some groups. Here are examples of the users we have during the pilot project. This includes AGRF. We have a consortia, Ozark, Australian and Reptile Genomics. We had the University of Melbourne Center for Cancer Research. We have CCI, Tilton Kids, Peter Mac, and a lot of the groups from WeHi as well. There is a link here to take you to the service itself, where you get all the information. But also, I encourage you to take a look at all the services as well we have on Australian BioCommons website. Thank you for your listening.